So today we're going to actually looking at differences of cubes. And we've been talking about factoring, and we've been talking about different types of factoring. And difference of cubes goes along with what we're talking about right now, which are cubic equations. So the first example that we're going to look at is a cubic equation, and we call this a difference of cubes because difference, as we all know, means to subtract. So for difference, that means subtraction. And then cubes means it's a cubic function. So let's get started and let's do our first example. Now, just like we did with difference of squares, we had a pattern with difference of squares. If you remember, a difference of squares is a difference of two squared terms. So for example, x squared minus 25. I've got x squared, and 25 itself is a perfect square, so I can write that as 5 squared. By the pattern that we have for the difference of squares, we were able to separate this into two binomial factors, x plus 5, x minus 5, based on the two squares that we have, the two bases. We have a base of x and a base of 5. And so this was a simple shortcut for us to factor a difference of squares. And the reason that works is because we don't end up with a middle term, because you have, when you distribute, you have positive 5x, negative 5x, it goes away, so you're just left with the first term of the quadratic and the last term. So let's look at difference of cubes. When I'm looking at difference of cubes, I'm going to take a basic equation here. So let's start off with x cubed minus 27. X cubed minus 27 is a basic difference of cubes because we don't have anything other than just the variable itself. So we want to first determine, do we actually have a difference of cubes? So let's look at this particular example right here, the 27. The 27 is a cubic. It's a cube. It's a perfect cube. If you were to take the cube root of 27, you would get 3. So 27 is actually a perfect cube, so it's 3 to the third power. Now that we've done this, what I'm going to do is I'm actually going to use the parentheses to help me establish my bases. So another way I can write this is x cubed minus 3 cubed. And I like to do this so I can actually see the quantity that I'm using to cube. So let's go and check out our shortcut again for factoring the difference of cubes. And we have x minus c, x squared plus cx plus c squared, based on your two bases, x and c. Those are your two bases. So when I look at this and I establish, I'm going to go ahead and I always write out the two factors. I always write out the two factors and I put the operation signs in there. That usually just helps me because then I can just go and substitute. So my two bases, up here I have x and c. Here my two bases are x and 3. So I'm going to follow this format here, and I'm going to substitute the x and 3 into the equation for my two bases, x and c. And the reason we use c is because a lot of times when you see a difference of cubes, especially in cubics, the c is a constant term. It's usually a number. Not all the time, but most of the time that's what we see. So my two bases. So following the pattern above, my two bases go in the first factor. So I have x minus 3. If I follow the second factor, the foundation here, I have x squared. So my first base, which is x squared, goes here. My second base, which is 3, is squared and goes here, so that's 3 squared, which is 9. And then the product of my two bases, multiplying these two together, is what is my center term, which is 3x. So now I've completely factored this difference of cubes. So that's a nice way that we can jump right to the factors themselves without having to do anything long. Now we've talked about methods that we can use like grouping, but this one, when you see it written like this, is not really formatted for grouping. So that might not be an option for us right off the bat. So let's look at another example. Okay, so we're going to do a second example here. Let's say that we have an example 8a cubed minus 64b cubed. What I'm going to do in this situation is the same thing. I have to determine, is this a difference of two cubes? First of all, let's look at the constants. Let's look at 8. Is 8 a perfect cube? And the answer is yes. 8 can be written as 2 cubed, 2 to the third power. Then we examine 64, and 64 can be written as a perfect cube as well. It is a perfect cube, so we can write it in terms of third power, which is a cubic. So I have 4 cubed b cubed. Now that I have 2 cubed a cubed minus 4 cubed b cubed, I can now establish my two bases. 2a to the third power minus 4b to the third power. And I can do this because both values are cubed and they're multiplied. That's implied there, that they're multiplied. So now I'm ready. I've got my two bases, and now I'm ready to do my examples. So let's follow our format. I'm going to put my two factors, my subtraction, plus, plus. Okay, so let's examine my two bases. In this case, my two bases are 2a and 4b. Those are my two bases. So I'm going to plug those bases in accordingly. So my first one goes here, 2a, and this goes here, 4b. Then I'm going to square my first term, which is 2a squared. So 2a squared to the second power gives us 4a squared. Our second base, which is 4b, when we square that, we get 16b squared. And for our center term, we use the product of our two bases, 2a times 4b, which is 8ab. So what we've just done is completed the basic example of the difference of two cubes.